Now let's look at the update phase. So that phase happens whenever the state or props of a component changes. As an example, let's look at our increment button. So let's go back to our app component. Here's our handle increment event handler. In this method, we're updating the state of app component. So this will schedule a call to the render method. So our app is going to be rendered, which means all its children are going to be rendered as well. Let's see this in action. So back in the console, I'm going to clear the console and click the increment button. So once again, you can see our entire component tree is rendered. Now I just need to clarify that when I say our entire component tree is rendered, that doesn't mean that the entire DOM is updated. When a component is rendered, we basically get a React element. So that is updating our virtual DOM. React will then look at the virtual DOM. It also has a copy of the old virtual DOM. That's why we should not update the state directly, so we can have two different object references in memory. We have the old virtual DOM as well as the new virtual DOM. Then React will figure out what is changed, and based on that, it will update the real DOM accordingly. So here, even though we have several counters, when I click the increment button, only this span is updated. Nothing else will be affected. Let me show you. So if I go to the Elements tab and select this element here, I'm going to click the increment button, and I want you to look at the span here. So increment, see, it gets highlighted because its content is updated. However, if I select another counter and click the increment button of the first counter, look, nothing is happening here. So there is no update on this part of the DOM. Now back in our counter component, I'm going to add another lifecycle hook here. Component did update. This method is called after a component is updated, which means we have new state or new props. So we can compare this new state with the old state or the new props with the old props. And if there is a change, we can make an AJAX request to get new data from the server. If there are no changes, perhaps we don't want to make an additional AJAX request. This is an optimization technique. So let me show you. Here we add a couple parameters, previous props and previous state. Let's do a console.log of previous props, as well as another console.log to show the previous state. Now save the changes back in the console. I'm going to clear the console and click the increment button of the first counter. Note that the value is currently 4. So click, look at the console. So ignore all the rendered messages. Look at the first previous props. So this is the props object that we're passing to this counter component. You can see the value of the counter was previously 4, but now it's 5. So we can write code like this. If previous props.counter.value is different from this.props.counter.value, then perhaps we're going to do an AJAX call and get new data from the server. However, if the value is not changed, perhaps we don't want to make an additional call to the server. Of course, this does not make sense in the context of our counter example, but what I want you to take away here is that with this method, component did update, we can decide whether we should make an AJAX call to get new data based on the changes in props and state objects.